So hey everyone, welcome. I welcome you all to the session on Bring Chaos into Development Environment. This is Sarna and Karthik, your host for this talk. So I would like to take this opportunity to welcome our speaker, Ramiro Berrelleza, who is one of the founding members of Okteto and has spent most of his career building cloud services and developer tools. Before starting Okteto, our speaker was an architect at Atlassian and a software engineer at Microsoft Azure. He's from Mexico and currently lives in San Francisco. So if you have any doubt or any queries, please feel free to type in the event chat or the Q&A section. And if you wish to interact with our speaker, do raise your hand so that we can invite you up on the stage. And you can also post your questions in the dedicated Slack channels. The link to those I'll be posting in a while in the event chat. So I hope you have a great session. So yeah, over to you, Ramiro.
That's an idea, Karthik. Thanks for that great introduction. And hi, everyone. This is great. It's very exciting to be here at Chaos Carnival. I'm very passionate about chaos engineering, so it's great to see all these events full of people sharing their experience, sharing what they like, and all these things they're learning. So today, I'm here to talk to you as a practitioner of chaos engineering. I'm going to talk to you about how you can bring chaos into your development environment. We've seen talks before of how to introduce, chaos engineering and CI/CD, even on production. I'm very partial to the dev experience. I want to talk to you about how I think you can bring more chaos engineering to that dev experience so that it makes your life easier every day. So please, at any time, put your questions, and I'm going to be able to answer them at the end. And if not, I will be in the Slack channel as well after the talk is over, where we can talk more about this. It's one of the topics I'm more fascinated and excited to talk about, so don't be shy. So I'm going to share my screen and get started. So if you want to connect later, I'm Ramiro Berrelleza in most places: Twitter, LinkedIn, Stack Overflow, Dev2, all the places where developers hang out. And as Aranya mentioned, I'm the founder of Okteto. At Okteto, we're building a platform to help teams build microservices faster on top of Kubernetes. So if you're curious, check it out. But today, I'm talking about the dev experience. So I'm talking about how you can bring chaos into your dev environment. So you just got to take a step back. And, I'm sure most of you know what chaos engineering is. That's why you are at this conference. But in case, just to kind of set a common context for this talk. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. This comes out of principlesofchaos.org, which is one of the quintessential sites on chaos engineering. And what this tells us is that, chaos engineering fits with all the other, testing techniques we already have. It's all about making sure that our systems are going to behave as we expect them in production. Production is that spot where, you have users, people are using your systems in many different ways. So you always want to be confident on how your service, your application, whatever you're building is going to behave. This is a relatively new discipline. If you remember, I've been a developer for now 10, 15 years. So way back then, developers focus on these three things. You'll get your code, you'll build it, you'll test it, and you'll ship it. This was back when, there were no microservices. We had monolithic applications where you could just run the entire thing in one place. It had very limited dependencies. So it was easy to know if things work or not. Back then, we focused a lot more on unit testing, end-to-end testing, integration, right? All these things you could do pretty much on your own machine. But then, technology has evolved, and microservices, they're kind of becoming the standard, right? A lot of places are already there. You'll see some monoliths, something in between. But the reality is that modern applications are no longer a single piece. You have your code. You might have multiple microservices, but you're also going to have a database. You may be calling some third-party APIs. There might be a DNS entry in front of you, your orchestrator, if you're using something like Docker Swarm or Kubernetes, your cloud provider if you're running on AWS. So we're starting to have a lot of different pieces to our applications, and that makes things more complex because more things can go wrong. This is not just about, hey, can my code work? It's about, will my code, with my dependencies, will everything work together the way I expect it? And will it fail the way I expect it? And that is key. And this evolution made the whole process of how we develop and how to deploy applications change. Now, it kind of looks more like this, right? Where you still have that code build test cycle, but that is just the beginning of this process. Then you're going to send your PR, merge request, change request, call it what you may, which ideally will trigger a different build. It will trigger a set of unit testings. And, as this change request advances through this pipeline, it might get merged. It will get deployed into integration environment. Somebody else might run tests there and eventually be deployed. So you see, now we're moving from this process where it was just you and your code to this orchestration where a lot of different stages are happening. And this is where typically you'll see chaos engineering fitting, right? You have this integration testing, you do some chaos testing, you might do other types of validation end to end, and then you deploy. And that is great, right? It's much better than not doing anything. But there's a very well-known statistic in our industry, which is that the later on this cycle that you find an issue, the more expensive it's going to be to fix it. And this is kind of obvious if you can take a second and think about it. If you find a bug in your ideas before you even write code, that's easy to change. You just think of, hey, this approach doesn't work, I'm going to do approach B. If you find a bug while you're coding, change the line of code, adjust, rethink. It's not as easy as when there was nothing, but it's still pretty simple. But as this gets farther down that cycle I show you, it gets more and more expensive because you have to redo a lot of work. You have to involve other processes, involve other people. When you get all the way to production, when it's really expensive because it's not just the cost of fixing the issue, it's also the cost that having that issue in production had for your business, for your product, for your customers. It could be everything from losing a paying customer to having an outage and having to call someone to come in the middle of the night. Like all these different things happen. So that's something good to keep in mind because as we have these new techniques, it is very important to, as people in the industry say, shift those practices left. And you can see it in this diagram, left towards the closest we can get to the beginning of the process because it's easier to fix things. And that's what I want to talk to you about today. If there is one thing that you get out of this talk is start chaos testing as soon as possible. Chaos testing, just like security, just like load testing, is not something you can just do at the end, checkbox, and you're done. No, it's very involved in how you build software, in how you test it, in how you design it. So the sooner you kind of put your chaos engineering hat on and look at what you're doing, the best is for everyone. So keep this in mind. What I want to show you after this is kind of a practical example of how I've been doing this with a bunch of different open source tools. But the core of the talk is this slide, is please start chaos testing as soon as you get a chance. How soon? Well, when you're writing code. That is the first time, even before, when you're writing a spec. But if you're not in charge of writing a spec, if you're not in charge of the core design, do it while you're writing code. As soon as you have something that works end to end, do some chaos testing. You don't have to do hours and hours of this, but do keep it in mind. Add it to your toolbox and kind of start doing it in the beginning. Because, well, going back to this chart that I like a lot, it is very expensive the longer you kind of delay this task. So, sometimes it's not up to us. There's an organization involved, so you can do what you can at the phase that you own, but, keep pushing for this to happen early on and kind of show them this slide and talk to them about how hard it is to do it at the end. So now that we kind of set that context, we're going to talk about what it takes to bring chaos to your development environment. For this talk, I'm going to focus on 3 core technologies that we use internally in my team to do this, and that I've talked to a lot of other people. You don't have to use this. There's many ways to introduce chaos into your dev environment, and the principles I'm going to be covering here are going to be the same for everyone. But I believe that these three tools do make the lives of teams easier. The first is Kubernetes. Kubernetes is a relatively new technology. It's been out for like 5-7 years, but it's really taking the industry by storm. At its core, Kubernetes is an open source container orchestration system that allows you to automate the lifecycle of your application. Everything from deploying, updating, scaling, checking the state, making it resilient. Today, it is the biggest open source project in the world. It was started by Google as something internal, then they open sourced it, and now there's a whole foundation behind it. Every major cloud vendor is supporting it. So it's really becoming the standard way of running containers. I like it a lot because there's a huge ecosystem behind it, and because it allows you to get compute almost instantly, which is great when you're developing. You'll see how this is one of the key pieces of my ideas on how you can bring chaos engineering into your dev environment. If you want to learn more, go to kubernetes.io. There's a whole ton of material on this. I'm going to be giving a talk on how to get started with Kubernetes next week, together with the founder of Sail and the founder of Layer CI. So I'll share the link in case you want to join that as well. Number 2 on this, and now we're getting into chaos testing, is Litmus Chaos. Litmus Chaos is my favorite chaos test engineering testing project. Was created by Maya Data, now the spin-off Chaos Native. And it's a cloud native centric way to do chaos engineering. I like it because just like Kubernetes, it's very easy to use. It's all manifest driven, which is great when you're writing code. It's all fits into this new paradigm of infrastructure as code, orchestration as code. It is part of the Cloud Native Foundation. It's a sandbox project, which means that it has a lot of support from the community, from different vendors. That they're always looking for all of these use cases. So it's a great project. Karthik, he's one of the main contributors, and you can see it on GitHub. Go to github.com/LitmusChaos/Litmus. Love their new avatar mascot, the little guy during experiments, because that's what we're doing. We're going to experiment with all these technologies and find how they can help us, build better, more resilient software. And finally, I'm going to talk also about Okteto. Okteto is an open source project that I started with one of my friends, and it helps you deploy pre-configured dev environments on any Kubernetes cluster. The idea with Okteto is that you are no longer going to have to install things locally and replicate your cluster, running all your services locally or your chaos testing locally. We're going to do everything on Kubernetes. So on this demo, I'm going to show you how you can combine these 3 open source products, Kubernetes, Litmus, and Okteto, to give you the ability to spin off chaos engineering tests super easy with your code as you are developing. Okteto, you can learn more at github.com/Okteto. And please, if you enjoy these 3 open source projects, if you like them, engage with us, the maintainers, start them on GitHub, share them with your friends. That's how we make them better, by having more people involved. That's one of the beautiful things about open source. So anyway, enough of context, enough of slides. Now we're going to go into this demo. I'm going to show you all the different pieces, how they run together. But rather than focusing on the code and what I'm showing you, I want you to really focus on the principles behind, on why this is important and how you can bring this to your team. Even if you don't use this piece of technology, even if you're not using Kubernetes, if you're not using Litmus, still the ideas behind them are important. So I want you to focus on that, and so we can all have a conversation on this and together make it better for everyone else. So I'm going to switch now to my VS Code. At any time, please, again, any questions, anything that is not clear, put it on Airmeet on the Q&A panel, and I'm going to try to stop and answer all of your questions. And you know what? We have a couple of questions, so why don't we take a second and answer those right now? I love when it's all, immediate and interactive, so please do more of that. The question is there a need to scale or extrapolate the scenario to fit production? And would that be against the philosophy of chaos engineering? I think when it comes to chaos engineering, when you're doing things at the dev stage, you have to really you don't have to run everything all the time. Just like with testing, you have to pick whatever gives you the most amount of coverage, the most amount of certainty at the stage you're at. Like, I'm not advocating that every single test that you run in production should be run on dev or vice versa. I think there are scenarios like, hey, testing that your code is resilient to the simplest, the VM shutting down, the database not being available at random times, network being slow, are things you can replicate in dev that makes it easier. Not everything. I think there's a high-scale chaos engineering that you need to do in a production-like environment, but other things are easy to do, and that's kind of what I'm focusing on here today. And that's a great question. And the other one is chaos as part of dev test. However, do you think there needs to be propagated to other environments, or will you classify chaos tests based on stages? I think you need to classify it. Not every test is useful at every stage. I like to focus on all the tests that are closer to the code and kind of like the first level dependencies to do them while I'm developing. Something more like, cluster-wide, if you're doing things like testing, what if a region comes down? What if your entire data center is not available or a core API is missing, is something that is better suited for other stages. But what's important is, just like with any other type of testing, is this continuous validation, this continuous input you're getting to make sure that you have all the information, to make sure your code is resilient. Nothing is perfect, but it's about making sure that things will behave as close to our expectations as we can. So I hope that I answered your question, but if not, please keep them posted. I'll try to take breaks during the demo, look at the questions, and kind of go back. So now I'm going to go to some code, and I'm going to show you some of the things that we do internally. I'm going to share this repo. I'm going to put the link on the Slack. If you go to my repo, Berrelleza in GitHub, you'll find it. It's just a kind of small sample of what we're doing here. So if you remember my slides, the first thing that I'm doing is I'm using Kubernetes. One of the first things that I want to kind of like insist on everyone is that the best way to bring chaos engineering into your dev environment, and really any other technology, is to make it super simple. That is, for me, one of the main advantages of using something like Kubernetes, is that everything is a manifest. Because if you are asking your developers in your team to run 10, 15 steps manually just to get started on chaos testing, they're not going to do it. Because we're always going to be on a rush. We always have other things to do. So really focus on automation. That is the first thing. And that's where whatever you're using, right? Kubernetes, if you're doing something like Vagrant, AWS, Pulumi, there's a ton of technologies to make infra deployment, your application manifest driven. So make sure you have that, and then either use a tool or build a makefile, any abstraction that allows your developers to just run one command and be up and running. So in this case, like going with that kind of like first tip, advice, whatever you want to call it, is look at this repo. This kind of exemplifies what I'm talking about here. This repo I have on the same repo, my application definition, my code, in this case is very simple. I have my chaos experiments. I have my dev environment defined. And don't worry, I'll go through each of these pieces. And a small README to tell developers how to do what they need to do. So for this demo, the first thing you need is Kubernetes. I recommend that you have a cluster for your developers. If you move to Kubernetes, I would advise against having every developer spin off and manage their own cluster. That being said, our company Okteto builds a product like that. You don't have to use that. Just want to put that out there. But do give your developers something easy to use. If you want to run things locally, I do recommend take a look at Docker Desktop. Their Kubernetes integration is, in my experience, the easiest to run locally. And for this demo, I'm using something else. I'm using K3S, which is a very minimalistic, very easy to use distribution of Kubernetes created by Rancher. In this case today, there's this company called Civo Cloud. I know the founders, I know the team there. They give you K3S as a service. Very easy to use, single script. You create a cluster in less than a minute. Not kidding, it's super fast. Check them out, and that's what I'm using today because it's the easiest thing to spin up a cluster. So that's the first thing you do, right, is you spin up a cluster. Second is you have your application there because you don't want your team to think about it. And kind of like the third step with this is give your developers a pre-configured dev environment so they don't have to hunt around for their dependencies. In this case, and you'll see why, but I'm really like container-based dev environments. Look at this dev environment, right? In this case, it has a base image that already has Python pre-installed. Why? Because for this demo, my app uses Python. I have kubectl on the container. I have Helm. I have Customize. I have my requirements pre-installed. These are all the things that I need to get started. If you provide them to your team on a container, then they can just simply spin up this container, get a shell there, and start working without having to install anything. And containers are super generic, which means you can use this on a bunch of different services. If you're using things like GitHub code spaces, Gitpub, or many other, or just running Docker locally, you can always just use this container and run. It integrates really well with VS Code's remote mode. There's a bunch of development. IntelliJ has something similar. There's a lot of development on how to use containers as your dev environment, and I highly, highly recommend you start there. It is, in my experience, the easiest way to provide your team with a pre-configured environment that just works anywhere. So today, that's how we're going to start, right? I have this. So in this case, I'm going to use Okteto, but you can use everything else to run your dev environment. So Okteto, if you look at this, it uses a very simple manifest. And again, touching on this, is a manifest that is on my repo. I don't have to think about it. I don't have to go get it somewhere else. And in this case, it just tells Okteto what image you want to use for dev environment, what command to run initially, in this case bash, because I want to have a full terminal, where to get code synchronized from, and which port to expose. So it's very simple. In this case, I'm just going to do like a very single thing. So I'm going to open my terminal. And all I need to do is go to the folder where you have your Okteto YAML and run Okteto up, UP. In this case, it's telling me, hey, it doesn't exist. Do you want to create a new one? Yes. There are many ways. Actually, before we get there, let's do something else in this case. In this case, I'm going to use a feature of Okteto where I have a predefined dev environment. This is because there's a few settings I want to take advantage of from Kubernetes, like the account I'm running in, compatibility with LitmusChaos. I'll explain this in a second. So in this case, I'm going to go back to my other terminal, the one that has the correct things. Do kubectl apply. Create this environment for me. And now Okteto up. Now that my environment is pre-configured through this manifest, I do Okteto up. Okteto will find it, and it will synchronize my code. So while this is running, let us go back to Ermit, see if there are more questions. No, we're good for now. Okay, keep them coming. So this, as I mentioned before, is going to give me a terminal into this dev container. All my code is here. It's synchronized both ways. This is what the Okteto open source CLI does. Works on any Kubernetes cluster. In this case, it's a K3s cluster running on Civo Cloud, but it could be Minikube. It could be something running on your company's cluster. It doesn't matter. And what's really cool is that, for instance, if you look at this, Python is already running there. kubectl, which is the CLI to interact with Kubernetes, also running there. So everything is pre-compiled, pre-installed. As a developer, I don't have to go around trying to figure out what I need to do. Okay, so this is the first step. I have the environment. Everything is pre-installed. I am ready to roll. I don't have to think twice about it. Okay. Second step is how do we make chaos engineering more accessible to our developers? Well, in this case, I'm using LitmusChaos. Like I mentioned before, I like LitmusChaos because of two main reasons. One, they follow the operator model, which means that I can install one instance of LitmusChaos in my cluster, and then I can just spin off experiments everywhere. And I can share this with everybody else on my cluster. So I'm no longer have to, manually handcraft this setup just for myself. I put on my repo, I have this manifest, anyone can use them, and anyone can benefit from this. So that is something very powerful when you think of this as not only for you, but for your entire team. So let me show you how that looks like. I pre-installed the operator. It's a YAML you install on your on your cluster. And what it does is it creates this hierarchy of objects, chaos engine, chaos experiments, and chaos results, which is what you use to interact when you're doing chaos testing. So in this case, I'm going to show you kind of one of the simplest examples of what a chaos engine looks like. So a chaos engine in Litmus is the resource you create, is where you map the application you're going to be testing with the kind of experiments you're going to run into this application and the results you expect. So in this case, you use this is their namespace and kind. In this case, I'm telling this experiment, hey, I want to have an application of type deployment that has this label app equals nginx. And I want you to run a series of experiments into that application. There's more things here, but I'm going to just focus on kind of like the key. I do recommend you go check the documentation and try things out. So you see here is experiments, right? In this case, I'm going to run an experiment called pod delete. Pod delete takes some parameters, but pretty much what's going to do is when the experiment is running, at some point with this interval of 10 seconds, it's going to delete a pod. This is useful because this is going to allow me to test, hey, what happens when one of my pods goes away? This is something that happens very commonly in Kubernetes, in Docker. Your container might not be there all the time. It might get deleted by mistake. It might be that the machine where it was running rebooted, and it's going to take a few seconds for that container to pop up somewhere else. So it's something important to test, and it's something really easy to kind of like get started with. And in this case, I have a second example called container kill. Same principle, but this one's going to try to kill the container. So I have these two things, right? And as I mentioned before, it's all manifest driven. It's all here. So running an experiment in this environment is as easy as typing kubectl apply run. But even that is a lot of steps. So what I did here and what I kind of show you is, I'm going to go back to my terminal. One of the things that I provide my team with is a script called manage. And it's something that I got inspired by one of the open source repos by Litmus. Manage is a script that contains all the instructions on how to interact with the dev environment. In this case, it has 4 commands: start, stop, test, and list. Start will deploy my application the way I expect it to be. Stop will stop it, will remove it. And then test will run the experiment I'm expecting, and it will run it and show me the result. And this is very important because rather than having everyone in my team have to be an expert on how to deploy the application, how to stop it, how to run an engine, a chaos engineering experiment, how to design it, you can have someone in your team or even in your broader organization create these resources for everyone. And you as a developer, all you have to know is that, hey, just run manage start and then manage test. And then that'll give you the validation you need that your application works as expected. So let me show you how it works. First thing we're going to do is we're going to run start. And you see this Python script is very simple. The code is there. All it's doing is installing the experiments that we want to make available and creating the resources. Nothing crazy, nothing out of this world. It's just giving your team the abstraction so they don't have to think about this. And that's something big. If you look at Okteto, what we put out there, that's a big topic we're pushing, which is you don't want your team to have to worry about all these things that are running under. They want them to worry about, hey, is my application resilient? Yes. Change your code. Test it again. Do these things. Don't worry about infra. Don't worry about being expert in all these other things. That's why you have other people. The important thing here is provide the rest of your team with the tools. So for them, it becomes second nature to just run an application. So in this case, the app is running. If we do you'll see get pod, you'll see there are things that are running. All right, cool. So now let's go back to our manage API. And if you remember, there is a test and list, and show list. It will show me, hey, I can run these experiments. I can run container kill. I can run pod delete. This maps, in this case, to what we have here on Chaos, these 2 experiments. All right, so what I'm going to do here is I'm going to do manage.py, and let's say we're going to run pod delete. test pod delete. Nope. Oh, test -t pod delete. And that's why you should have help invest in all these things. And if you notice, just like the previous command, what this is doing is, hey, is deleting the existing experiments, all results. It's creating all the resources I need. In this case, is using create, calling a manifest so that this manifest will interact with Litmus Chaos to actually invoke a pod that's going to be spin up to run my experiment, run my validations. If you look at this, we're doing a lot of different things at different level. A lot of things are happening, but me as a developer, I don't care about those things. I have this little CLI that me and my team built, where you run the experiments, you put your commands there, and that's all I need to do. Now, here I'm logging all the things because I do like to know what's going on. This is something that if things don't work as I expect them, I can then copy these logs and send them somewhere else. But what's happening behind the scenes is that Litmus is spin up my chaos experiment, is randomly waiting until this pod will get deleted. In this case, my application is an Nginx server that I built with some data, like some pages that I pre-built, just a very simple thing. But this could work with any app. Then it's going to run the validation. And then whenever this is done, it's going to tell me, hey, your experiment passed or not, and the logs. If for whatever reason the experiment fails, I'm going to have all the information I need to fix it, change my code, run one command, redeploy my application, test it again, iterate as I develop. This is something that doesn't require me to committing changes, to having to go wait for CI/CD, to send a pull request and then test this in pre-production, right? I'm doing this as I'm developing. And that is the key here, is we're putting together Kubernetes to give us instant compute, Litmus Chaos to give us the abstractions to run and design chaos experiments without having to be experts on that. And we're using Okteto to give us a pre-configured dev environment that runs in Kubernetes with all of our tools pre-installed. And then we have the CLI that I built to make the life of my team easier. And these four components together is one way that we are using internally to bring chaos to our dev teams is, hey, I'm going to make it as easy as possible to you. If you look at this, really, this line is all you need to do to run a chaos experiment. You don't have to be an expert on any of these technologies to be able to run this. You just have to remember Okteto up, manage PI test, pod delete, and you're done. And then if it fails, change your code, run this again, and be done with it. And everything is in your repo, which is very important. You can share it with your team. You can make changes and everybody else benefits. You can design more experiments, all those things. On top of this, Litmus also gives you a portal where you can create more complex experiments, which is very useful. They now have also a commercial offering of this, where you can have this for your entire organization. There's a hub where you can share experiments. And all of these things you share, you can take them, put them back into your repo, and share them with the rest of the team. And that is, kind of this theme is make sure that all this work you do, it's in your repo, one command, and you run it, one command, you get your results, because that way, people in your team are going to get used to, hey, this is how we do chaos engineering. This is how we get started. And it just makes everything easier for everyone else. So just to kind of remember, I put here on my repo, because I want people to remember this, 5 tips on how to bring in chaos into your dev environments. Number 1, automatically deploy your application from the repo. Any developer in your team needs to be able to clone the repo, run one command, and deploy your application. So if you don't have these things, this is where I recommend you start. Number 2, make it easy and one command to run your chaos experiments on the repo. Again, you don't want to think about it, build, redeploy, one command, abstract all those things away. You don't have to get fancy. Use a make file, use whatever you're familiar with. Just have a command for your team to do that. Number 3, make sure this command automatically validates the chaos experiments and the results, and make it easy to share the results, because when things work fine, no one has any questions. It just passed. When things fail, you want to make it easy for your team to share these results with somebody else and get, help. If I take those logs I show you, I put them on a Slack, someone in my team who's more senior might know what's going on. Or if they don't, well, together we can figure it out. But if there's no way for them to know what I'm seeing, if there's no way for them to know what's happening, then I have to develop expertise to understand the entire stack so I can explain to them all these moving pieces, and then it just takes a long time. And that's not what we want to do here. We want to be able to do it quickly so that everyone sees the benefit and just they put them as part of their normal tool chain. The same way that a lot of IDEs now auto-save your file. You don't have to think about, write code, Control S, or things like Eclipse or IntelliJ. They will auto-build your Java jar. So you don't have to think, which command do I run to compile and then to copy? Same principle. Just make it super easy. I don't want to think about it. Just run the results. At some point, we might be able to just have continuously running all these things. We're not there yet, but start with this 4 things. And number 5, specific to, if you're going to go to Kubernetes, don't force your developers to run a cluster each. It's very hard. It requires, again, a lot of expertise and infrastructure, not an application. So make sure developers don't have to know this. Write a script. Use a user-friendly distribution. If you're doing it locally, do something like K3s or Docker desktop. Just make it super easy. And if you see a trend here, the trend is make it easy. Give them scripts because you don't want them to think about it. Because the moment that they have to think about it is the moment they're going to stop doing chaos testing. Because just like, in VS Code, you need testing. One click, your test runs. You want it to be as close to that as possible so people don't see it as a hassle and they just get the benefits. And then, bonus, get realistic data on your dev environments. Make sure that, you have data. It's not just code. A lot of issues in production come because of data. So don't start there. That is hard. Start with the scripts, deploy your application, run your chaos testing, but do at some point invest in having data there as well, because that really is part of what makes things break once you go to production. So, just to close on this, 2 things. One, let me make this bigger. GitHub.com/rberrelleza/chaos-carnival-2021 is where all this code, all those tips are. If you want to use the tools I show you today, Civo Cloud, Litmus, and Okteto, there's information there. There's even some coupons to get some free kind of like dev accounts there if you want them. Importantly, support, start, and collaborate with Litmus Chaos and Okteto. They're both open source. So I have some questions here. Very, very interesting questions. I'm going to try to go through them as fast as I can. So first, from Bernard, say what you want is to test your service's ability to gracefully degrade. Which of the steps intended to keep it simple would continue to apply for you as a developer? Great. So from degradation perspective, I always like to start by testing the components. What happens if one of your dependencies is missing? If your database is not there? If you're running with 1 replica instead of 5? All those things make sense at the developer perspective, because those are the things where your code is going to be involved, right? Like you need to code for reconnecting to your database, to maybe using default values when your database is not responding anymore. If you're talking to other services, what happens if they're like super slow? All these things are stuff that we can test during that cycle that really build a lot of like the degradation. I've seen a lot of teams try to go for like the big tickets from the beginning, but there is something you can do kind of to get started there that will have a tremendous impact in production. I've seen companies where no one thought that the database connection might be turned off because they always think the database was on. And just testing for that and adding code for like, hey, on disconnect, wait and reconnect was enough to increase their SLAs immensely. So you can start small and start building these things. Another question is by Karthik. Says, traditionally, observability is a big part of chaos engineering. In other words, dev test is generally more focused on functionality. This is where chaos results and probes checks should help? Yes. The world where observability didn't matter is a world that we're no longer living. As our apps get more complex, telemetry, logging, observability is a key component of our applications. Our applications today are not just our code, they're our code, our configuration, the runtime, our dependencies. So it's important to bring those things in. And that's one thing I really like about Litmus, and I'm glad you mentioned it, which is this whole concept around profs and checks to make sure that your application recovers, that it recovers on time, that it's not left hanging. And again, going back to Bernard's question, these are the kind of things that we should be focusing on at the dev cycle. Because if you're waiting for pre-production to test, if you have a retry on how you call another service, it's going to be a lot harder to test these things. If you do it when you're writing your code, it's like, oh yeah, I forgot the retry. Let me add a wait and a loop, or let me import this retry library and do it myself. And you're close to the code, so you're seeing the impact on this. So that is very important. And that is one of the features that I wouldn't start there, like start with just kind of like the basic delete, stop, start. But it is very important to start the same way that I'm talking about bringing chaos into dev environment. You need to bring observability. You need to bring telemetry. You need to bring the dependencies that you can, because the most realistic your dev environment is, the easier it is for you as a developer. And that is a lot of the things that we do at Okteto are very focused on that and those things. So I think those are all the questions that we have from what I'm seeing here in Urbit. I love the platform; it's really cool. I want to thank everyone for this. I'll be sharing the slides, the repo on Slack. Check it out. There's some coupons there for Zero Cloud, for Okteto, links on how to get started with Litmus. And thank you for having me. And I hope this was useful. And enjoy the rest of the conference. Have fun, and I'll see you online.
Yeah. Thank you, Ramiro. I hope the audience would find this very interesting. Yeah, so I would meanwhile I would encourage our audience to keep interacting with Ramiro in the dedicated Slack channels. So yeah, enjoy the session, enjoy the Chaos Carnival. Thank you. Bye everyone.